This is our video on recursion in Java, and this is part 2. Part 1 also we discuss about recursion. So it is the next video on that series, and it is specially meant for ISC classes 11 and 12. So first we'll see what is recursion. Recursion is a technique of making a function call itself. This function that is called again and again, either directly or indirectly, is called recursive function. So in this recursive technique, normally we call a function within the body of the same function again and again. So it means same method is being called within the body of itself. Now there are few advantages and disadvantages. So the advantage is this provide a way to break down the complicated problems into simple problems which are easier to solve. So here what we do, basically we divide a problem, a major problem, a bigger one, a complicated one, to the smaller ones, and we deal with each one by one. Now the disadvantage is a recursive program has a greater space requirement than the iterative or a looping program. So it is more or less, you can say, is a replacement of looping, but the problem is in looping it doesn't need much space because the loop iterate within the same memory block again and again, whereas in recursive function each uh, uh, run of a particular recursive method need a separate space. So what happened in that case, the each function call remain in the stack or in the memory until the base case or the condition is being reached. So it needs separate space for each iteration, you can see, in general. So it need more space. So now straight away we will go to the program and we will see how we can work with uh, recursive functions. For that I have already created one program over here. With the help of this program we'll try to understand. So first we'll go to this program and we'll check what in this program. Actually this program has a class called recursive fact, so we are computing the factorial. For computing factorial we normally use looping construct, but here we are doing with the help of a, recursive construct, you can say, or recursive technique. So we have a class called recursion fact, and in that class I have this main method, and you know how to compute a recursion. Let's say I want, sorry, the factorial. If I want to compute a factorial of 5, that means if 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1, that is 120. And same way we can compute the factorial of any given number. So now what we are doing in this main method, we are calling this function factorial 5, which we have defined over here, and it will compute the factorial of 5. But now we'll see its definition part, how this factorial method has been defined using recursive technique. So for that I have this method called factorial, which is taking an argument. In this case we have passed value as 5, so it will compute the factorial of 5. Now inside the body, have a look at this. If n equals to 1, that means if the number whose factorial I want to compute is 1, in that case, factorial will be printed or written as 1. That means the factorial of 1 is 1. This is the base case. This is a base case, or we can say it's like a condition. When this condition will be satisfied, this looping or the recursive uh, construct will come to an end, and it is must. As you know, for any looping construct also we should have a case, uh, we should have a condition. When the condition is satisfied, the loop stops. Same way, when we have this base case in a recursive construct and the condition reaches to the base case, the loop or the recursive construct will stop. If this is not there, then this recursive function call will never ends and will go to infinite. Now other than this, if value is not 1, any other value, let's say 2, 3, 4, 5, in this case 5, then we'll go to the else part. And in else part, what actually we are doing, we are actually calling the factorial method within the this method itself. As you can see, the name of this method is factorial with the argument of integer type, but inside the body of this factorial method we are calling this factorial method again, but now with the value n minus 1, and we are multiplying this with n. So this is just the statement to make it clear. Factorial of, let's say, n, that number is n, that is multiplied by factorial of n minus 1. So just to make it more readable, we have this statement, but actually what it is going to return if the number is not 1, other than 1, it will call this method again with, let's say, the value is 5. So what will happen? There was a call for a factorial with the value as 5. So when it reaches over here, then there will be another call for a factorial method with the value n minus 1, in this case 5 minus 1, that is 4. So it will be 5 multiplied by 4. Then there will be another call for 4. When v reaches again over here, then it is 4. But here 4 minus 1 is 3. That means 4 multiplied by 3. This way it continues till the time, or you can say it is going to be decremented till the time n reaches to 1. So now we'll compile and see. This program has been compiled successfully. Now we will run it and we'll see how it works. So as soon as we are running this program, we can see the factorial of 5, that is 5 multiplied by, it was n minus 1, that is 4. So 5 multiplied by, there is a call for factorial 4. But when factorial with the value 4 was called, then there was another call for n minus 1, that is 4 minus 1, that is 3. So it is 4 multiplied by factorial for 3. Then same thing continues for 3, it is 3 multiplied by n minus 1, that is 2. And for 2, there is 2 multiplied by 2 minus 1, that is 1. And then it comes to an halt. So meanwhile, it has already been these all the calls for the factorial for 5 4 3 2 1 has been put on a stack, and when stack is full, they start resuming, and then it compute the factorial for 5, for 4, for 3, for 2, and for 1, and give us the value as 120. So as you can see, this is something, you can say, a replacement of looping construct. So this is one way how we can design or develop our program using recursive technique. So this was all for today, and thank you very much.